Two and a Half Admins, episode 68. I'm Joe.
I'm Gary.
And I'm Alan.
And here we are again, but without Jim, because he is in his sick bed. Bless him. Hopefully he'll be better for next week, but we'll have to see. In the meantime, we're stuck with you, Gary.
Yeah, sorry about that. You just have to put up with me, I'm afraid.
Yeah. People may know you from the Linux After Dark podcast, but if they don't, you work for a cloud company, let's just say that, but your views are your own.
Yes, indeed.
All right, well, before we get started, we've got some plugs. First of all, Alan, you joined me on Late Night Linux Extra recently, which we'll link to in the show notes, talking about FreeBSD. Thank you for doing that.
Yeah, it was my pleasure.
And also keep sending in your Christmas AMA questions. We're going to do an episode at Christmas that is all kinds of questions about all sorts, whether that's tech-based or just random philosophical things, just whatever you like. It'll be a bit of fun at Christmas. So keep sending those in. show@2.5admins.com. And BSDCan 2022 call for papers. I can't believe that we're getting so close to the new year.
Yeah, the conference will be in person in June. And so the call for papers is out now. And I'm looking very much forward, I hope, to actually getting to see people in person.
Right, well, link in the show notes as usual. An article I found on the Register actually has changed its headline. Now the headline is, "The Dark Equation of Harm versus Good Means Blockchains Had Its Day." I actually preferred the original one. It's long past time for a cost-benefit analysis on blockchain. Either way, it's quite a scathing attack on the very idea of blockchain, saying that it's just a bit worthless and useless, really.
It's interesting. It's, I think, a bit suffering from the common thing we see of, okay, we've come up with this cool technology. Now, if only we could find something interesting to do with it. And we've seen kind of like we see for both like developers with frameworks and languages and tools, or even just sysadmins and new interesting toys and DevOps stuff is, I've learned about this new thing, so I'm going to use it to solve my next problem rather than what might be the best solution for that problem. I want to play with this new thing. It's how things end up using MongoDB and things like that. This is how I used MongoDB the first time, was mostly because I had learned about it and it was an interesting thing. And I had this project and I'm like, yeah, we can do that in MongoDB. Even though it didn't necessarily make sense for what we were doing, it was a good excuse to get to use it. And it seems kind of cryptocurrency kind of bought into this idea of the blockchain and it's great for this stuff, we should use it, without actually considering that the things they tried to say that the cryptocurrency was going to do, like have really low transaction fees. It turns out the transaction fees are massive and it's really slow to confirm a transaction. It's like, do we really want to go to a world where confirming a transaction takes longer than it takes to process a credit card? Because if it's supposed to replace using credit cards to buy things, then maybe it needs to be at least that fast, right? Not, buy it and 15 minutes later, you'll be able to confirm that the money is actually the other person's now and you can't just take it back and spend it differently.
Well, the argument against that I've heard is that you could have caching servers that use more traditional databases that make it faster for the people actually using it. It's just a technological problem that can be solved.
Yeah, but what if one of them disagreed? Then what do?
Well, indeed.
If you've already told people for sure that transaction is okay and then it's not, then the whole service falls apart.
If I've already left the store and my credit card's been accepted, it's a little bit late by that point to turn around and tell me that actually I still owe you $100 or whatever.
But what about divorcing cryptocurrencies from the underlying technology? It is essentially a distributed database that's got hash checking built in.
It is, but I've still yet to see a really compelling use case that's gone into like wide-scale production for it. And we always talk about supply chains and things like that being a really good use case for blockchain, but I don't really see anyone using it at large scale. And I sort of agree with the article that it still feels like a solution that's looking for a problem, and outside of cryptocurrency, I just haven't really seen anything.
Yeah, like I'm all for the idea of making it easier to track things and be able to do product recalls. Like I got the phone call, a voicemail the other day from Costco saying that the Tums antacid tablets I bought were being recalled because they might have had the metal shavings in them. Like 6 months after I bought it, but they knew everybody who bought any that had that lot number, and they were able to call the people and leave them a voicemail. And sure, you could use the blockchain for that, but if you're Costco or Walmart or someone and you're implementing this, you don't need the features of the blockchain for this, because it's your database, you'll trust it. Now, if you're doing something one level up where, you're getting data from multiple people and you need to make sure that once they give you the data, they can't go back and change their copy of it or something, then maybe the blockchain makes sense. Like the use case I thought of is, CRT.sh, the certificate transparency stuff, where the big companies that issue SSL certificates have to log every certificate they issue so that we can detect things like if there's another, DigiNotar, where they issued certificates for Google.com to Iran and so on. But, we already have this kind of idea of immutable logs already that aren't blockchains. It's kind of a related technology that's been around for a while, and they didn't end up needing it. The blockchain doesn't actually solve the problem better than what they already had. And kind of like we were saying for the supply chain stuff, we've seen that if you had two competing things, one using the blockchain and one using a normal database that worked, which one's going to actually succeed? Probably not the blockchain one.
But the advantages with blockchain are that it's distributed. You don't have to worry about setting up backups because that is built into it. You don't have to worry about hash checking, that's built into it.
Sure, but the not having to worry about backups is just only if enough other people actually care to have a copy of the database.
But if you're a major international logistics company, say, sending shipping containers all over the world, and you set up your own private blockchain in 5 or 6 data centers around the world, then that kind of makes sense to me.
Well, that would just be a replicated database in that case. If to be a distributed database, like you're saying, you would need the other copies to not necessarily be in your control. So then you're like, every one of the people shipping stuff with us has to have the entire blockchain downloaded and add their stuff into the blockchain and send it back to us or whatever. And it gets much more weird, right? You're not just talking about I have circular replication databases where there's one in Toronto, one in Fremont, California, and one in Portland, Oregon. And if you do an insert on one of them, then it passes it to the next one and the next one around in a circle until it gets back to itself. And my database exists in 3 places now.
Yeah, but it's not distributed, right? It's not that someone else is writing to your copy in Portland.
Right.
Say, it's a slightly different way of thinking about it. Say, it's like you're not going to get me shipping my eBay package to someone, downloading a copy of your blockchain, right? And updating it and then sending it back to you to verify that I've shipped a package. It's just not necessarily a practical use case.
Well, yeah, it's kind of this tweet that we found where it says on the pitch deck for a hot new startup, it says, we leverage an open source technology called SQL. Turns out it's millions of times faster than common blockchain technologies and allows us to do innovative things like delete data. And it's centralized, which drastically makes it easier to manage. That brings up the point that if you had this giant logistics blockchain, what if somebody makes a typo on the input and now they need to change it, but the typo is there forever and the incorrect value is there? It's like, oops, I put one too many zeros when I declared the value of what's in this container. And it's immutable.
Yeah, but you could have a second edit in there that shows that you made the mistake, but then you fixed it. Then it's just like the Git style, having a history, which actually would be good. That shows who's making mistakes and who's having to fix them.
Showing proof that there was an edit is useful, yes. But at some point, do you need all of the blockchain from the shipping stuff from 20 years ago? At what point does it make more sense to delete the old data and not keep it around? So I don't know that the blockchain is a great solution for anything. It's an interesting technology and maybe somebody will find a good use for it. But as the article points out, right now, the only thing that's being well enabled by cryptocurrencies is ransomware.
Yeah, and I think you have to take a step back. I mean, the original title for the article, right, was it's time to do a cost-benefit analysis. And I think there is a huge amount of harm that the blockchain has caused, right? So not only in terms of things like GPU prices, but there's been, extreme environmental damage from the power that these big mining farms are causing to mine cryptocurrencies.
And in particular, that's not necessarily a problem with the blockchain technology so much as the cryptocurrency decided that they're going to have this difficulty factor that kept going up, and then they were going to give away the currency as part of that. If it had been architected differently, just the ledger part of blockchain doesn't necessarily require this huge amount of GPU, but does have the downside that if somebody has more than 50% of the amount of GPU you are using to log the ledger, that they can then go and make it say whatever they want. So if they don't keep amping up the difficulty, then someone can forge the blockchain too easily.
It's just resulted in this problem where the only real use for blockchain has caused huge amounts of damage, and no one's come up with a tangible other use for it yet. So it's become something where I'm so tired of hearing about blockchain that it's going to take, some real world-changing project to be based on blockchain to convince me that it's not just a technology that needn't exist.
Yeah, and it's going to have to be very successful for rather a long time and not fizzle out for me to move off my position of anybody who says blockchain should just be ignored.
Yeah, absolutely.
Okay, this episode is sponsored by Linode. Go to linode.com/25A and see why Linode has been voted the top infrastructure as a service provider by both G2 and TrustRadius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and their upcoming bare metal release. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. A mysterious threat actor is running hundreds of malicious Tor relays. This is an article I found on therecord.media. And apparently since 2017, there's this mysterious threat actor that has been dubbed KAX17 that seems to be running more than 900 servers as part of the Tor network, which is around about 10%. And nobody knows who it is or why.
Yeah, and interestingly, unlike a lot of malicious actors in Tor that usually try to run exit nodes and muck with people's traffic on the way out, these ones are mostly middle relays and some entry points, or guards as they're called in the Tor lexicon. And so their role is to encrypt and anonymize user traffic. And so I think they found that at one point, if you were just a random user trying to connect to Tor, there was about a 16% chance you were going to enter the Tor network through one of these KAX17 servers, which would mean they would know your actual IP address. And then about a 35% chance that your traffic would go through one or more of their middle relays, which they might be able to then, relate back to that Tor entry node. And then about a 5% chance that you would go through an exit node that they control. And so that made it much easier for someone possibly to figure out who you are by being able to connect, your entry into the Tor network, which is the part that's most sensitive because it goes back to your regular routable internet address. And then with the middle relays to get an idea of where it is that you're going to exit Tor as well.
Yeah, and it was interesting to me that this has been happening for quite a while. Say the article notes that there was servers removed as recently as mid-November this year. Say it seems like either this went unnoticed for quite some time, or has been a pretty prolific problem for what seems like quite a while now.
Well, it does seem like the Tor project has been trying to deal with this, but this entity, whoever it is, just keeps coming back.
Well, and part of it is that there's no strong correlation between a Tor server and who runs it. It's literally just generally an email address that they put in when you set up a node, and it turns out a bunch of nodes just have no email address. And just because it has no email address doesn't mean it's one of these KAX people, but there's lots of them with no email addresses that do seem to be related to this. They have a graphic here. You can see where they occasionally shut down a whole bunch of these. Like back in October of 2020, the Tor security team removed all of the exit nodes they thought were related to this KAX17. But then you can just see later on, you just see more pop up as not exit nodes instead.
Yeah, and the Tor admins kind of note that in the mail excerpt that's in this article that for anyone running relays, the way that you build trust is to get more connected to the community. And it just makes you wonder, how do you build that trust and make sure that people running particularly entry nodes and exit nodes are actually people and not, either nation state actors or some kind of anonymous, malicious group? It seems like something that's very difficult to do if you're just relying, like you said, Alan, effectively on the email address that people are putting in when they register the node.
Yeah, and the whole point of Tor is it's supposed to be anonymous and run by a whole bunch of different people. But if you just have 9,000 Tor nodes, how do you know that some large amount of them aren't controlled by one entity?
What goes into hosting a Tor node then? Are we talking like a seriously beefy box or?
No, like you can do it on a relatively small thing, or you can limit it to a relatively small amount of CPU or memory or whatever on your machine.
So this could be just VPSs then?
Yeah.
Because 900 seems like a lot, but if it is just VPSs, then it isn't necessarily a nation state actor, is it?
No, I mean, it would be relatively easy to spin up 900, machines across a range of cloud providers and use it like that. But I think if you're orchestrating machines at that kind of scale, specifically to run, various Tor routing nodes, you probably have something a bit more nefarious and probably have some kind of motive, I would wager.
The first thing they thought is it could be some kind of academic research project or something, but they note most of the time when you're looking at researchers from a university or something, that's usually coming from one or two autonomous systems or AS numbers, like different ISPs, whereas this KAX thing is 50 different ones. Usually they have less than 100 nodes, not over 500, and they usually do provide contact information.
Yeah, and also the Tor project is fairly well connected to the research community. I'm not sure about that one because, like we saw with the hypocrite commits in the Linux kernel, people doing academic research don't necessarily go about it the right way.
But an academic researcher going out of their way to stand up 900 machines across various ISPs, different ASNs, seems like a far stretch.
Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to learn more about it, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions or feedback, show@2.5admins.com. One of the other perks of being a patron is you get to skip the queue, which is what Dennis has done. He writes, I currently have 3 servers that I maintain for personal use, a file share and Plex server, a backup server, and a Nextcloud server hosted by Linode. I recently started to use Ansible for maintenance tasks like routine OS updates. What is the best way to configure passwords with Ansible? Using the same sudo passwords for all my servers doesn't seem very secure. What is the best way to configure Ansible to use different passwords per server?
So I think there's probably 2 ways around this. If you're at the scale of just 3 passwords, probably setting a different sudo password on each server. And then when you pass in the playbook, you can do tac ask-become-pass, and that will just prompt you for the sudo password. If you're doing it at a larger scale, you probably want to look at using something like Ansible Vault. Ansible Vault will then allow you to store those secrets, and you can just call them out as variables for the various different servers. But at the scale you're at, probably setting different sudo passwords and doing the --ask-become-pass is probably the easiest way around it.
Oh, okay, so that's a bit different than what I was thinking. I was thinking more along the lines of, in my deployments where we use Puppet, which has a persistent agent that keeps running, it manages what the root password is on each of our machines. And so in our manifest, which is kind of like the playbook, we have the hashed version of the password that gets written into the shadow file. In this case, Puppet stays running as root and is controlling what the sudo password is for, me when I SSH into the server. And in our case, that's the same on most of the servers, but it's because you'd have to get in with my SSH key first before you could even try to run sudo.
Yeah, so with Ansible, you'd probably do the same thing depending on where you're running the playbook from. I'm going to assume that this playbook's just being run from a workstation, and they're just doing Ansible playbook and then just passing in the name of the playbook. In which case, yeah, they'll probably use their key to auth to the server, but then you have become basically an Ansible, which is where you then escalate up to root, and you can do a become method of sudo. So yeah, I think at this scale, probably just doing the ask become pass and passing in the password is probably fine. But yeah, in a lot of the bigger deployments, you probably want to use Ansible Vault, pull out the secret from there, and just remember to re-encrypt the Vault file before you put it, anywhere else.
Okay, this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Okay, Ken says, one of your cousin podcasts about self-hosting was recommending burn-in tests on new hard disks with the goal of discovering if a drive is going to fail or have errors early on in its lifespan because of the statistical bathtub curve. He's talking about self-hosted. I know Alex does this. We keep meaning to do a collaboration episode with them. Maybe we should get onto that in the new year. Anyway, Ken continues. I recently got a few new drives and thought I'd do the procedure they recommend, which involves one of several scripts available via GitHub. In the end, I decided to just do the individual smart test commands and the bad blocks test command manually. I also decided to do this on a couple of different Raspberry Pis. The full bad blocks write, read, 4-pass test actually takes over a week to complete. After some troubleshooting, I was able to get the smart commands to execute, and they reported no problems. However, bad blocks revealed problems. The very first brand new drive I started doing these tests on has been showing a bunch of errors. It's found 32 errors so far and counting. Not having ever run these tests before, this surprised me and made me doubt the results or the value of doing this test at all. I've been trying to figure out if there is some other source of potential errors in the method I've attempted. Here are some possibilities I've considered. And he wrote a big, long thing for all of these, so I'm going to have to try and summarize it. The first one is a USB to SATA bridge. And he is shucking drives, essentially, but trying to test them before he's taken the drives out of the USB enclosures so he can get his money back if something's gone wrong.
USB to SATA can introduce errors. If you've not shucked it yet, I wouldn't expect so much there. As you note in your longer text here, you know that Jim and I were going to make faces at you for buying USB hard drives in the first place.
They're so much cheaper, though.
For a reason, because they're so much worse.
Are they, though?
Yes, they literally do what's called binning, right? They manufacture the hard drives trying to make them all good, but not all of them come out good. And they're like, oh, is this one good? Yes, then sell it as a hard drive. Is this one not so good? Well, then check it in a USB thing and sell it to some schmuck.
I think that's just snobbery.
No, I think ask any of the drive manufacturers.
Okay. Well, the other two theories are Raspberry Pi hardware, which I know that Jim is very down on and you're pretty down on generally. And the other is software, because he's been using Raspberry Pi OS and he's wondering if Ubuntu would be better. And he basically summarizes it with, have I just gone down a pointless rabbit hole with all of this? Is it worth running the bad blocks test on future drives? Or is there something wrong with his methods?
So the first thing I would want to know is after bad blocks found errors, when you check smart, so I'm not actually talking about the smart self-test, but checking smart and the error log, which I think is smartctl-x, does the drive actually acknowledge having had errors? Did it actually fail to read part of the disk? Or did it might actually be able to say, it was a CRC error, or the error was on like the SATA bus. It was something, it didn't go over the cable correctly. Because, the cabling can be a very likely source of transient errors.
Particularly if you're using a USB to SATA bridge to a Raspberry Pi.
Yeah. The Raspberry Pi itself isn't so much the problem, it's just the power is going to be lacking and flaky there. And yeah, it's all kinds of mess. So yeah, my biggest question is, after bad blocks found the errors, does smart log actually show the errors? Because, you said you did the smart self-test, but generally that's, it reads a little bit from each section of the hard drive. The short test really doesn't read very much. And even the long test, reading the entire drive end to end turns out would take so long, it's probably not useful. So even the long self-test on with Smart doesn't check every single sector in the drive, whereas BadBlocks is going to. And so if SATA acknowledges that there were errors, then it may be that there's a problem with the drive. And sometimes, if you overwrite, if you write a sector and you fail to read it and you overwrite it again and it reads fine now, then maybe it's okay. But, as soon as you're getting into this area of it's suspect, that's when I don't want to use the drive anymore. Lots of people will be like, oh, it works fine now. And it's like, yeah, but, it's suspect now, so it doesn't get anything important put on it. And this is where Jim would say, well, I have enough backups and replicas that I don't care.
Yeah.
But to me, $100 for a better disk is worth more than the time I would spend messing with it when it does screw up. And so I tend to buy like the Seagate Iron Wolf NAS drives because they are just better.
And so do you do the burn-in test with them when you buy them?
I do not. For my high production stuff that I generally buy from an integrator, they've done a 72-hour burn-in test for me before they ship the hardware to me. So I don't have to, but no machine at my house has ever run BadBlocks. I generally just plug it in and go. And if it runs into an error in the first 3 or 4 days, I will know and be able to deal with it in RMA or whatever. And if it doesn't, then it's probably going to be fine for years, right?
The way I end up doing it is I run a full smart test, a run or two of BadBlocks, check the smart logs. If it all looks okay, I run shred across the drive, and then I put it into production. But I'm also guilty of shucking drives out of cheap NAS enclosures that I find on Black Friday, right? So for me, it's probably worth doing because I'm running a RAID 5 of 4 disks and I don't have that.
You don't have a buffer there.
Yeah, I don't have that buffer there. So I want to make sure that if I'm putting an 8 terabyte or a 12 terabyte disk in an array, that it's going to be okay. Because if one of my disks fails, I'm screwed and that's my data gone. But like you say, Alan, if it's in an enterprise setting, like, when I've been running big SANs and stuff before, chances are Dell or EMC or whoever it is have run a burn-in test on that drive for me anyway. I'll put it in, and there's usually enough of a buffer there that if it fails, then I don't care.
Yeah, like at my house, even all my things are at least RAID Z2. So if one of the drives is bad, I'm going to find it, and it's not going to cause me a problem. And if I do, it's because of the bathtub curve, it's most likely to happen in the first 3 days. I'm not going to have actually managed to fill the array yet in the first 3 days. And so from that, I will know that I still have my other copy that I was going to build this array out of, right? And so I don't have that much risk of it screwing up in the first 3 days. Whereas the production stuff, I drove to the data center and spent a day installing this. If I have to go back the next week and replace a bunch of drives, that would be a pain. But when it's at my house, if it fails in the first 3 days, I'll just deal with it.
Yeah, when my use case is more, it's at my house. I have a box that has 4 disks in. And if I put one bad disk in there, then I'm in for a real headache because I'm restoring from backups that are 20 miles away.
See, I just treat any storage device like it's about to die.
Well, yes. When people ask me to autograph their copy of my ZFS book, my autograph literally says, your drives are plotting against you, and ZFS at least lets you know, kind of thing.
Yeah. That's why I do shuck drives and just treat it like, well, it's probably going to die, so I make sure I've got a decent backup of it. And if uptime's important to you, then have a proper RAID setup.
Yeah, deep enough RAID that you can handle a drive or two failing. In the end, running BadBlocks isn't going to hurt anything. When you get errors, that does raise suspicions about the drive, and I'd be a little suspect. Like, I think you were testing more than one drive here. If all of them got errors, then that's maybe a bit different than if just one of them did. If just one of them did, I'm pretty sure that one's a bit flaky, and I wouldn't trust it.
But don't do it on a Raspberry Pi, not to do the tests, surely. Like, once it's in production as a backup of a backup of a backup, maybe, but you don't want to be doing tests like this. There's just too many variables with a Pi, it sounds like.
My BadBlocks runs that I do, I pull the side off of a machine, I put the disks physically in the machine, mount them properly, and just run BadBlocks on either a Debian system or an Ubuntu system or whatever happens to be installed. But yeah, use a proper machine, use cables and stuff and a PSU that you know are good, and just eliminate everything, kind of every variable you can other than the drivers would be my advice.
Yeah, for sure.
My shucking tip is, especially with the WD My Book, that is very easy to shuck and unshuck without anyone knowing, okay, maybe if they started to examine it, but if you get it off Amazon, let's say, and the drive dies having taken it out and taped over the third pin and everything, you can put it back to its virtually new state. If you watch the videos carefully and don't force anything, it's pretty easy to do it.
I just generally don't buy Western Digital. Although I'm very, very, very sad that they bought HGST because those were my favorite. So I would still use what were the HGST drives, but I've had really bad luck with like the Western Digital 1 terabyte enterprise drives.
We'd better get out of here then. We'll be back next week when hopefully Jim will be joining us. Thank you very much, Gary, for coming along. It's been nice to have you.
No worries.
You can find me on Twitter at Joe Ressington.
I'm at This Geek Tweets.
And I'm at Alan Jude.
We'll see you next week.